Tycho Brahe. Okay, Tycho Brahe or something like that. Okay, so what he did was he just looked at the sky, the night sky. Okay, look at the night sky, and so what do we do? What does he do? Well, with a telescope, of course, with a telescope, and then he noted the positions of the stars, like this constellation, this particular. So you have constellations, right? So this constellations, the concept of constellations is like very old, right? So let's say a constellation naam bolo. Ursa Major, whatever it is called, Ursa Major, Ursa Minor. So, like you have constellations, you have some very famous stars, okay, in the sky. So what he did was he just kept a record of, he kept a written record of all the positions with time. Basically, he had a year long of notebook register in which he said, okay, this, this, let's say, North Pole star was at this point of time on this day, it was at this point. Okay, so it changes, okay, because it changes. Okay, so this he had a very elaborate, basically a record book. Okay, a very elaborate record book. Kepler was the student of Tycho Brahe, so he studied this record book. He didn't, okay, he studied this. Kepler studied this and devised three laws. Okay, so there are three various things he observed. The first law is there are laws. Okay, laws. How many? First, second, and third. Okay. The first law is these are called Kepler's laws of planetary motion. Of planetary motion. Okay. The first law says, let's say in our solar system, how many planets are there? 8. And which is, are they revolve around what? Sun, no? Yeah. So the this is the sun. Then a planet revolves in an elliptical orbit. Ellipse, okay? Ellipse. Okay, ellipse is a shape. Is a shape, okay?
Sir, could you go to the previous page? I was copying.
Yeah. Can you see?
Yeah. He made 3 laws for what?
Planetary motion.
Yes, sir, done.
So ellipse, what the shape of ellipse is a shape, it is not a circle. Ellipse is not a circle. Okay. And then make a circle, okay? Make a circle. Circle क्या होता है कि if there are two axes, so we'll make two axes, okay? One axis horizontal axis, one vertical axis. Red is the circle, okay?
Sir, I can't see.
Oh,
1 second, sir, please on it.
oh, there is problem from my end. Can you see now? Yeah. The circle में क्या होता है? This radius and radius is this is r. This is also r. Okay, the radius is same everywhere. It's a radius. It's same everywhere. But in an ellipse, what happens? Along one of the axes, the length is higher. Along one of the axes, the length is smaller. So I will mark another line first. Okay, an ellipse will look like this. Okay, and this length. So if this is 0, 0 on the axis, and this point is a, 0. Okay, this point is minus a, 0. Similarly, this point is 0, b, and this point is 0, minus b, and a is more than b. A is more than b means yeah, this distance is more than this distance. Okay. Also, right, this length is called the major axis of the ellipse. Major axis, okay. And consequently, ये वाले को क्या बोलेंगे? इसको minor axis. Major axis का length कितना है? लेंथ कितना है? ये पॉइंट क्या है? a, 0. ये माइनस a, 0. तो लेंथ कितना हुआ? 2a. Suppose this point was 5, 0, and this point was, जोर से बोलो, उसमें आवाज जाए, और जोर से बोलो. Then what is this length? 2 into 5. Okay, and the length of minor axis will be 2b. Okay, understood? Okay. Then there is a quantity called the eccentricity of this ellipse. क्या है eccentricity? ECCENTRICTY. Eccentricity. Eccentricity. Do you know the English meaning of eccentricity word? Okay. A person is said to have an eccentric behavior when that behavior is kind of very weird or quirky about him. Okay. If you can, out of 10 people, if you can identify, okay, this ka behavior to aisa, then it's called eccentric. Basically, the word eccentric means identifying. Eccentricity is a physical mathematical quantity. It is 1 minus b square by a square. Okay. 1 minus b square by a square, the whole root. Okay. Also, you should understand for a circle, this b, sorry, a, this is n, and this b, right? For a circle, a equal to b, right? The eccentricity for a circle is how much? अगर b और a बराबर होंगे तो b square by a square will be 1, and 1 minus 1 is, so e will be 0. सर्कल का eccentricity 0 है, ठीक है? एलिप्स का eccentricity इतना होता है. अगर एलिप्स और फ्लैट हो जाए मतलब इसका eccentricity, सपोज ये वाला एलिप्स है, ठीक है? एलिप्स और फ्लैट एलिप्स है ना, पूरी जैसा है ना, तो उसका देखो b और छोटा होगा, a और बड़ा होगा. इधर देखो b छोटा होगा ना और a बड़ा होगा, तो ये नंबर विल बी वेरी छोटा. तो ये आंसर 1 के पास आएगा. अंडरस्टूड? ठीक है. अगर b 0 ही हो जाए, मतलब ये पूरा ऐसा फ्लैट ही हो जाए, एकदम फ्लैट, तो एसेंट्रिसिटी कितनी हो जाएगी? 1. अंडरस्टूड? फॉर अ स्ट्रेट लाइन एसेंट्रिसिटी इज 1. for a straight line E is equal to 1. ठीक है, सर्कल की एसेंट्रिसिटी कितनी है? 0. सर्कल इज नॉट एसेंट्रिक, वो एक हर तरफ एक उतना ही होता है, ठीक है, लेकिन एलिप्स, you have understood this right? ठीक है. Do you have you can you tell from this that E is less than 1? E is always less than 1. Can you guess from this? Root of 1 minus something. So if you have root of 1, see, because this is 1 minus something, this whole thing will be less than 1, right? That whole box is less than 1, and you take a square root, so square root is also less than 1. So E is always less than 1 for ellipse. For ellipse, लिखो इसको, E is less than, लिख लिया जल्दी जल्दी. Okay, now coming to the important part, if you have minor axis, major axis, your ellipse, okay, then there are two important points. There is one point which is called focus 1, and there is one point of focus 2, symmetric point, and this point is AE comma 0 and minus AE comma 0. Okay, by the way, what was this whole length? See your note and tell me. See your notebook. What was this whole length? A. A. This whole length was A. Okay, and E was less than 1, right? So AE will be more than A or less than A?
More.
You are multiplying E to a number, right? A, and E is less than 1. So less than A, right? So this point, this distance is AE, okay? Fine, that's why it is AE comma 0. And this point is minus AE comma. So but it's basically these 2 points are at a distance AE, okay? AE at either the ends. And these points are called focuses. So this is focus. Okay, focus 1, focus 2. Focus 1, focus 2, understood? Hmm? Now, right. The first law says, the first law, the planets move in elliptical orbits around the sun. Around the sun, with the sun, with the sun at one of the two foci. Foci is the plural of focus, okay? So focuses word कुछ नहीं होता है, क्या होता है? Foci, ठीक है? Two foci of the orbit of the elliptical orbit, ठीक है? तो सन किसी एक फोकस पे होता है. अंडरस्टूड? ऑल्दो अप्रोक्सीमेट के लिए कभी कभी सर्कल ले लेते हैं, पर सर्कल होता नहीं है, ठीक है? क्या होता है? एलिप्स होता है. हर ऑर्बिट एलिप्स है, ठीक है? दूसरा एक चीज ये है कि देखो, अगर एक एलिप्स बनाया तुमने, ये तुम्हारा
Sir,
रेड,
what does it say of the two?
व्हाट? It is at
It
one
says
of
the
the two
plan.
focuses. It is sun is one of the two. Sun is at one of the two focuses. Okay. Now understand this, that सपोज देयर इज अ प्लैनेट, ओके, ये प्लैनेट है, ठीक है। तो यू शुड अंडरस्टैंड हाउ प्लैनेट्स रिवॉल्व, ओके, प्लैनेट देखो कैसे रिवॉल्व करता है, ऐसे ऐसे, ठीक है, अंडरस्टूड। जैसे अर्थ है तो ऐसे रिवॉल्व करती है, ओके, अराउंड द सन, ठीक है, ओके, समझ में आ रहा है ना ये? ओके, नाउ अब if this is the orbit of the sun, an ellipse, sorry, orbit of the earth, and it revolves around the sun, then let's say there is another planet, और sun ना यहाँ पर है, किस पे है sun? Let's say sun is in here, okay, let's say there is some other planet, let's say it is other planet, बोलो Mars, okay, so अगर Mars है, so Mars orbit is something different, some different ellipse, okay, Mars orbit will be some different ellipse. Let's say that ellipse is this ellipse, okay, it's a bigger orbit, okay, ellipse उसका बड़ा है. तो for some planets the sun is, you know, sun will not be at the same focus for, it might not be the same focus for Mars also. It might be that the, or let's say छोटा बोलो Venus, ठीक है, तो जो Venus का ऑर्बिट है, तो मार्स नहीं, मार्स हटा रहा हूं मैं, ठीक है, और Venus बना रहा हूं, Venus का ऑर्बिट might look like this also. If the Venus orbit is this, okay, let's say if the Venus orbit is this, then out of the two focuses of the Venus, sun is at the left focus. Basically, और एक चीज और ये देखो, इट्स अ स्मॉलर एलिप्स, राइट, तो उसका अगर एक फोकस ये है तो दूसरा फोकस यहाँ होगा, समझ में आया? या फिर ऐसे समझ लो कि ये है, ठीक है, दिस इज द वीनस ऑर्बिट, ठीक, तो उसका दूसरा फोकस वहां पे होगा, ठीक है, अंडरस्टूड। वीनस की ऑर्बिट के कितने फोकस है? दो है, और सन उसमें एक में, किसी एक में, फाइन। ऐसा भी हो सकता है, ऐसा भी हो सकता है, वन थिंग मोर इज पॉसिबल, दैट ऑरेंज इज नॉट द केस बट द ग्रीन इज द केस। ग्रीन केस में क्या है? these two are focuses, understood? So you can't decide at which focus, okay, but it is at one of the focus of that orbit, understood? ठीक है, और जो फोकस होते हैं वो ऑर्बिट का प्रॉपर्टी है, वो सन का प्रॉपर्टी नहीं है, अंडरस्टूड नो? जैसे कि फॉर द रेड ऑर्बिट, अर्थ ऑर्बिट, वन फोकस वाज दिस हियर एंड वन फोकस दिस, राइट? वीनस का अगर ऑरेंज ऑर्बिट होता तो ये फोकस होता और ये होता ना, इसका और इसका कोई रिलेशन नहीं है, कोई रिलेशन नहीं है, अंडरस्टूड? और इसका वैसे इसका और the focus at of the Venus and the focus of the Earth also don't have relation. It is just that, you know, because sun is there, so it is the focus of either of the focus of Venus or Earth. Okay, fine everyone, समझ में आ गया ये? दूसरा जस्ट जीके है, इट इज नॉट इन योर सिलेबस बट जीके ये है कि मरकरी, वीनस, अर्थ, मार्स, जुपिटर, सैटर्न एंड यूरेनस, नेपट्यून, इन सबका जो ऑर्बिट है, दे आर इन द सेम प्लेन, दे आर इन द सेम प्लेन, बट जो प्लूटो था ना, प्लूटो का ऑर्बिट ऐसे था। one more reason why it was removed from the planet, ठीक है, प्लैनेट का लिस्ट, समझ में आ गया? लिख लो इसको, कितना Written. Written now. Okay. Next thing is, first is done, no? First law, this was the first law, okay? Second law is, second law is very, second law is tricky. So listen carefully. How many, what time does Earth take to go around the sun?
365 and 1 by 4th a day.
Okay, let's say that is
Days.
65 days, okay? So if the elliptical orbit is like this, no, I should make it symmetrical. Symmetrical? Yes, sir. Ellipse bana, but at what cost? Can it be rotated? No. Can I make it this again? Yes, I'll try making this again. Very good. Okay. Now see, sun is at one of the focus. So let's say sun is here. Okay. This is sun. अर्थ कैसे जाती है अभी? अर्थ जाती है मस्त अर्थ को दिखाएंगे. अर्थ ये ग्रीन ग्रीन प्लैनेट, ग्रीन एंड ब्लू प्लैनेट. सो अर्थ इज, अर्थ इज ओके एंड इट गोज लाइक दिस, राइट? ये बोलता है this line, so this line which joins, this line which joins earth to the sun, imaginary line, the imaginary line which joins sun to the earth at any point of time, this is the imaginary line, right? It sweeps equal areas in equal intervals of time. Okay, I'll repeat, the imaginary line joining the sun and the planet sweeps equal areas in equal intervals of time. So let's say Earth went from position 1 to position 2, okay? Then the line with the imaginary line which joins was initially like the orange one, and after it has reached 2, it will become like the second one, right? Do you understand this, everyone? The area which it covers is given by, do you understand, it is this pink area? Right? Let's say from 1 to 2, it took, let's say 40 days, okay? That's example, okay? Example, it is 40 days. So Earth was at place number 1, and then at place number 2, it was 40 days afterwards, okay? Okay? And then you wait for more 40 days. After 2, you wait for more 40 days, the Earth would have gone here, okay? At position 3. This again 40 days from position 2, okay? This is 40 days. So this region is 40 days from position 2, and this whole total is, this total is how much? How many days? 80 days, right? And
Yeah.
this is 40 days. So if you now join the imaginary line joining the Earth and the sun, it will be like this, right? And the area which will be covered is yellow area, right? So the theorem says, the second law says, the pink area is equal to yellow area. Understood? The pink area is equal to yellow area. What is same in both of them? Time. Understood? ठीक है? Have you understood this? ठीक है. Now you write, each planet revolves around the sun. Each planet revolves around the sun in such a way that the line joining the planet to the sun sweeps over equal areas in equal intervals of time.
In such a way that
The line joining the planet and the sun,
the line joining the
planet to the sun, sweeps equal areas in equal intervals of time.
sweeps
Equal areas in equal intervals of time. Okay. Done.
yeah.
ठीक है. Sweeps equal areas in equal intervals of time. There is a, you have made this, make it and then write area 1 equal to area 2.
Sir, you're in mute. You're in mute.
Oh, sorry. I was on mute. I'll repeat. So now you're not waiting for 40 days. You're just waiting for, your time interval is 1 hour. Okay. So what we'll do is, just for 1 hour, we'll wait. The sun, the earth will move from here to here. Yes or no? Okay. And the area which will be formed is, do you understand? Like I'm trying to make a triangle, right? Yes or no? You know? It is a triangle, except for the fact that, इसका लास्ट वाला ये ट्राइंगल है, इसका बस ये लास्ट वाला पार्ट कर्व्ड है ना. अगर ये लास्ट वाला पार्ट कर्व्ड, इफ इट वाज नॉट कर्व्ड, देन इट वुड बी अ कंप्लीट ट्राइंगल, राइट? यस, ठीक है. नाउ लेट अस से अर्थ वाज हियर एंड यू वेटेड फॉर 1 hour and it went here. Okay, right? So this is also a triangle, right? Yes or no? ठीक है. See, because these two triangles area must be equal, these two triangles area must be equal, and like averagely, if you see triangle 1, which is a yellow triangle, and the triangle 2, pink triangle, the height of the yellow triangle is much bigger than the height of the pink triangle, average. You can consider both of them to be, right, right angle triangle, whatever you want to. Basically, area of triangle is half into base into height, right? Do you agree with this, that the height of the two triangles are drastically different? Approximately the yellow triangle is double the height of the pink triangle, right? So if the area is same, what should be the relative length of their bases?
The pink base should be doubled.
Very good. The pink base should be double, right? That means on the orbit, the earth is moving more, right? Yes or no? That means the velocity, the speed of earth in region 1 or region 2 where it is more?
Sir, could you repeat the question?
I'm asking because it's the same time interval 1 hour, right? 1 hour, in 1 hour in the region 1 Earth has moved more. It should reach, it should move more, right? Because the area of triangle it has to make equal.
Yeah.
Therefore, Earth moves faster when it is closer to the sun, right? And it moves slower when it is farther away from the sun, right? This planets move faster when they are closer to the sun, and planets move slower when they are farther away from the sun. Now, if this is the orbit, tell me at which point, and this is the sun, okay, sun is here. Sun is here. At what point in the orbit is the Earth farthest from the sun? Point करो वहां पे screen पे.
So what?
At which point in the orbit you are farthest away from the sun? यहाँ पे बता दो. अगर यहाँ sun है तो कहाँ?
At
0 ना?
at A, comma B at the right side.
ये वाला, ये point ना?
Yeah.
इस अगर यहाँ sun है तो ठीक है, इस point को बोलते हैं apogee. क्या बोलते हैं? Apogee, okay? And at which point you are closest to the sun?
The left side.
Yes, this point is called perigee. लिख लो. What is apogee? Apogee is when the planet is farthest from the sun, and perigee is when the planet is closest to the sun. Because speed at apogee v1 and v2, which is more, v1 or v2? v2 is more, right? v2 is more than v1. ये डायग्राम बना लेना फिर से, और then you write speed at perigee is more than speed at apogee, okay? Okay, understood apogee perigee? Okay, speed is and slowest is apogee, okay? The third law is that लिखो, the cube of mean distance of a planet from the sun, the cube of mean distance of a planet from a sun,
The cube of what?
mean distance,
Spell it.
mean median,
Oh.
mean distance.
Huh.
of a planet from the sun is directly proportional to the square of time it takes to move around the sun. Is directly proportional to the square of time it takes to move around the sun. Okay. R cube is proportional to T square. T should be capital. T is capital because it is the time period. It is also called time period of motion. Okay. Time period of revolution. जैसे कि T for Earth is how much? Yeah, T of Earth is 365 days. Okay. Or time questions. We will do some questions on this. Wait a minute. Okay. अच्छा इसका एग्जांपल ये है. Let's say T of what is the mean distance? पहले सोचो mean distance क्या होता है? Mean distance of a planet from a sun. So for example, see the Earth distance from the sun is not a fixed distance, right? It is at different points. It is, for example, it is when the Earth is here, it is this. When the Earth is here, it is this distance, right? When the Earth is here, it is this distance. When the Earth is here, so you take the average or mean of these distances. Okay. If you take the average or mean of these distances, you will get one particular distance. Okay. That distance is called. That distance is here r. Okay, mean distance. So for different planets, this is different. Like for example, r Mercury and r Earth, which is bigger? Earth is bigger, right? So and basically ये क्वेश्चन ये बोलती है कि r Mercury cube is proportional to T of Mercury square. This equation also says that r Mercury by r Earth the cube is equal to T Mercury by T Earth का square. Okay, understood? Write this.
नारायण रेड्डी बिल्डिंग नियर कर्नाटका
ठीक है. Written no? Wait a minute.